for 2. So does everybody understand how we find the height on a parallelogram? It's not the slanty line. It's a straight up and down dotted line, Holden. Okay? Now, again, it really becomes difficult if we're told to find area of a parallelogram when it's got squares on it. Because I've got partial squares, don't I? They're not all nice and neat like it was on our rectangle. That really makes it more difficult, doesn't it? So thank goodness we have a formula. And since a rectangle and a parallelogram are real similar to each other, their formula is very similar. Length times width. Over here it's going to be base times height. Okay? So it'll all be pretty simple. We're just taking two numbers and multiplying. Ever since 3rd grade you've been multiplying, right? So look over here. Area of this bad boy right here. Area of this bad boy.
60 inches. Well,
I don't just throw down answers in my pre-AP class.
5 times 12.
Area equals
5 times
length times width. 12 times 5.
Equals
Go off to the side.
60.
No, it doesn't. It's 0, carry my 1. 60. Area equals 60. Now, whoa! Go back to the front here.
Square inches.
We've got to remember, our measurement today is not length, inches, or things like that, is it? Meters. Our measurement in area is squares. Remember, we're covering something with squares. Our answer is the number of squares it takes to cover it. So our answer has to be
2.
Answers will be in square units because we're finding out how many squares. So in this first example, it is 60
To the power of 2.
It's the 60 squares made with inches.
Square inches.
Square inches. Squares made out of inches. Is everybody with me?
Yes, sir.
Now, let's go back to order of operations where we talked about exponents. Did we have an exponent that was also called square?
2.
The 2. So we can